Today we're gonna do kind of like I don't want to call it a crash course, but basically like a summary of quadratics, right? Now, we did quadratics in detail. The students who were with me before, we did it in detail in Form 4, and all the notes and class recordings are up on YouTube. So if, as we go through the stuff today, you find yourself not following or like you have to refresh your memory, which you might actually have to do, I suggest going back to those YouTube videos and watching them over. You don't even need to watch the whole thing. Just watch enough to get your juices flowing again, right? So first things first, what is a quadratic? A quadratic is an expression or equation in which the highest power of x is 2. So the general format of a quadratic expression is ax squared plus bx plus c, right? Where a, b, and c belong to the real number system. And also a a cannot be equal to 0 because if a is equal to 0, then the quadratic is it wouldn't exist because there will not be a term in x squared. And if you just have a term in x, which 1 is the highest power, there it would be a linear equation. So a quadratic equation or expression is one where the highest power of x is 2. So for example, if you have 3x squared minus 5x plus 2, this is a quadratic expression because the highest power of x in this expression is 2. All right, and a is equal to 3. So a is your coefficient of x squared. In this expression, the coefficient of x squared here is 3. B is, well, let me use a different color for B. B is negative 5. So it's not just 5, but it's negative 5. And then C is equal to 2. All right, so the general form of a quadratic, ax squared plus bx plus c. A, b, and c belongs to the real numbers, and only a cannot be equal to 0. B can be equal to 0 and C can be equal to 0, but A cannot be equal to 0, right? So some examples, let's just look at some examples quickly, and I want you all to tell me what is A, B, and C, right? So what is Zayden? I want you to answer me this first one. If you have x squared plus 3x minus 7, what is A, B, and C in this quadratic?
These are these. X squared well will be equal to 1, so A is 1,
Hmm?
B is B is 3, and
Yeah.
C is 7.
-7, right? So the sign in front of it is -7. Thank you. Right. What about if you had, guys, 5x squared minus x plus 1? Fired, what is A, B, and C in this expression?
Um, A is 5, B
Hmm?
is what, and C
Hmm.
is what.
Correct, right? So A is 5, B is -1, and C is just 1. What about Jazara? 4 minus 2x squared. What is A, B, and C here? Jazara, B and C? In 4 minus 2x squared?
A is -2 and B is 4.
A is -2 and B is 4. And what about C?
A is 0.
C is 0, right? C is 0 because there is no term in C there. All right, guys? Now, quickly tell me, is um Is this a quadratic? 5x cubed plus 2x squared minus 1. Is this equation, sorry, is this expression, this one that I just wrote here, is this a quadratic? Done. Is this a quadratic? 5x cubed
No,
plus
miss.
2x squared?
No,
Right.
miss.
Zayden, why is it not a quadratic, Zayden?
Because it have two A's. You know, it's
Because
a
it
A,
has,
B, C, and
no, because the highest power of x in this equation is 3. Right? So the highest power of x has to be 2 in a quadratic. So in this one, the highest power of x is 3, which actually makes this equation a cubic equation. Not equation, sorry, this is not an equation, it's an expression. The reason it's not an equation is because it's not equal to anything. All right, so one of the very important things, guys, is being able to identify that you are, in fact, looking at a quadratic, and also being able to say what is A, B, and C. All right, so that is a checkpoint for you. Make sure that you know when you're looking at a quadratic, well, how to identify that this is a quadratic, and then what is A, B, and C. All right. Next, we have, so with a linear equation, that is an equation in which the highest power of x is 1. So like 3x plus 1 or 2x plus 4, it's in the form y is equal to mx plus c. That is when you graph that, it would be a straight line, right? But a quadratic makes a curve and it's called a parabola, right? So the graph of a quadratic is called a parabola. Graph of a quadratic is called a parabola or parabola, however you want to pronounce it, right? It's called a parabola. So it's a parabola, right? And it's a characteristic U shape. And it can either be facing this way or it can be this way. All right. So this is the graph of quadratics. They're either it's a characteristic U-shaped graph, either upside down U, so it's U-shaped, either upside down like this, or right side up like the second one, right? And there are some features of the quadratic of a quadratic graph that you need to know. So let me give you an example. For the expression ax squared plus bx plus c, when a is greater than 0, that is when a is positive, you will have a minimum curve. So the curve looks like this, right? And this is called a minimum curve. Called a minimum curve. A minimum curve occurs when the coefficient of x squared, that is a, is positive. So like an example of a quadratic that would have a minimum curve might be x squared minus 6x plus 5, for instance, is equal to 0, right? That would be the quadratic. That it would have a shape like this, a minimum shape, right? A minimum curve. When a is less than 0, that is when a is negative, the curve is is flipped upside down. So it's an upside down U, it looks like this instead. And this is called a maximum curve, right? A maximum curve occurs when the quadratic, when a is greater than when a is less than 0. So like an example of that might be if you have one that, let's say it's minus 2x squared plus 3x, for instance, you'd have a maximum curve because here in this example here, a is negative 2. So when a is negative, the curve, you have a maximum curve. When a is positive, you have a minimum curve. So in this example that I stated here, x squared minus 6x plus 5. A here is 1, which is positive. It's greater than 0, so you have a minimum curve. All right, so let's look at what the features of the quadratic curve now. So I'm just gonna draw axis, two axes. This is my y-axis and this is my x-axis. All right, so let's say, so this is y and this is x. And let's say I had a curve that looks like this. Actually, I wanna put it more this way. Right. So let's say I'm looking at this minimum curve, right? Now in this curve, there are some very important features. One is where it cuts the x-axis. So where it cuts the x-axis, these 2 points here, that's called the roots of the quadratic equation. The roots or the x-intercepts is where the quadratic cuts the x-axis, all right? And actually, when you solve a quadratic equation, the values that you get for x, that would be the roots of the equation. So this is your solution to the quadratic equation. So when you solve a quadratic, the two answers, typically you could get two values for x. You could get x is equal to one number and then x is equal to another number. And so you have that. Those two values will be where the graph cuts the x-axis, right? Sometimes you could get one value for x or one solution for the quadratic. It means the graph will only cut the x-axis at one point. And then you can also have no solution. So the quadratic doesn't even need to cross the x-axis, right? So the roots or x-intercepts they are found by solving the quadratic. So it's the solutions of the quadratic equation, right? And then you also have what we call the minimum point. So the minimum point, as the name suggests, is the lowest point on the quadratic curve. As you can see, there's no point on the curve itself that is lower than this point. And that's probably why they came up with the name minimum point. So your minimum point is where the quadratic is the lowest point on the quadratic curve, right? And it is also called the vertex, right? Or your turning point. So guess why? If you think about it, if you look at the curve, right? If you look at this quadratic curve here, you have all the time uh it's going down from left to right. As you move from left to right, it's going down. And then when it reaches that minimum point, it turns around and it goes back up. So perhaps that's why they called it the turning point, right? The turning point, vertex or minimum point is when the lowest point on the quadratic curve is the minimum point, the vertex, or the turning point. And guys, you want to try to make sense of these things. The name gives you an idea of what is happening there. Some names don't really make any sense. Like for example, quadratic itself. That doesn't really remind me of any other word or any other phrase. So I have no clue what that is. Other than the fact that it is a equation or expression in which the highest power of x is 0 is 2. But words like minimum point or turning point, those words can suggest something to you. The phrase minimum point suggests that it's the lowest point on the quadratic curve. And likewise, turning point, the curve turns around at that point, right? So the minimum point or vertex is the lowest point on the quadratic curve. And then you also have what we call the axis of symmetry. So you would know from before that there is, well, what a symmetry is, right? When we have a shape that is symmetrical, or if you have to draw lines of symmetry on a shape, it means that the shape can fold along that line and it will be equal on both sides, or it's like a mirror line, right? So your axis of symmetry, this is your axis of symmetry here, right? Your axis of symmetry passes through, as you can see, it passes through the minimum point, right? So your axis of symmetry passes through the minimum point. And therefore, the x value, right, because this axis of symmetry will pass through the x-axis. Any vertical line on a graph passes through the x-axis. Any horizontal line will pass through the y-axis. So the axis of symmetry, the x coordinates of the minimum point, is also going to give you the equation of the axis of symmetry. Any vertical line on a graph, the equation of that line is going to be x is equal to something, meaning, so it's wherever the graph cuts the x-axis. So let's say this axis of symmetry here is 3. Sorry, the x-coordinate here is 3. This straight line is passing through the point 3, 0. Then the equation of the axis of symmetry will be x is equal to 3. If it was passing through the point on the x-axis where x is equal to 5, the equation will be x is equal to 5. If it was passing through the point on the x-axis where x is equal to -10, then the equation of that line will be x is equal to -10. So the equation of your axis of symmetry is simply where the graph cuts the x-axis, and also it is the x-coordinate of your minimum point, or your, well, when we look at the maximum curve, the maximum point, right? So far, the important things about the quadratic curve are your roots or x-intercepts, which is where the graph cuts the x-axis, your minimum point, vertex or turning point, which is the lowest point on the quadratic curve, and then your axis of symmetry, which is where you have a straight line, the axis of symmetry, that passes through the minimum point. The curve is symmetrical about that axis of symmetry. And then there's one more thing, which is basically where the graph cuts the y-axis. Where the graph cuts the y-axis over here is called the y-intercept. And that is true for any type of graph, because even a straight line would have a y-intercept. It's where the graph cuts the y-axis. And in terms of a quadratic, in terms of the general form of a quadratic, a curve that looks like this is the minimum curve here. This is called a minimum curve. This is called a minimum curve because it has a minimum point, right? A minimum curve. So in this, the general format of this curve here would be ax squared plus bx plus c, where a is positive, as we just went through, right? So when a is positive, you have a minimum curve. Your axis of symmetry, you can find it by taking minus b divided by 2a. So whatever b is, you could use minus to get the equation of the axis of symmetry. You can actually use the formula. Let me put this in a different color. You can use the formula x is equal to minus b over 2a. And that would give you your equation of your axis of symmetry. But not only that, it would give you the x-intercept of, sorry, the x-coordinate of your minimum point, right? So for this curve, this one is where a is positive, it's a minimum curve. The axis of symmetry. To find the equation of the axis of symmetry, you do x is equal to minus b over 2a. And then the y-intercept, which I was talking about just now, the y-intercept is actually your c value, right? So whatever c is in your general quadratic, that is the y-intercept. So I'm going to show you with an example, and we're going to sketch a curve, right? So with a minimum curve. So let's do it. Now let's say we had the quadratic. Let's say we had the quadratic x squared minus 6x plus 5 is equal to 0. Now you can only solve a quadratic equation. You can factorize or even completely square or write in completed square format and a quadratic expression. but you can only solve a quadratic equation. And that is true for any algebraic equation and expression. You can simplify expressions, you solve equations. So as you may recall, there are three ways that you can solve a quadratic equation. One is by factorizing, two is by using the quadratic formula, and three is by completing the square. This quadratic can actually be factorized. So I'm going to factorize this quadratic. So factorizing the left-hand side, x squared minus 6x plus 5. I don't know if you all recall the steps in factorizing a quadratic. In this one, a is 1, b is -6, and c is 5. So I need to ask myself, what two factors of ac, in this case it'll just be 5, so a is 1, B is -6, and C is 5. So AC here is 1 times 5, which is 5. So I need to ask myself, what two factors of 5 will add or subtract to give me -6? So 5 is a prime number. The only two factors of 5 are 1 and 5. So to get -6, I'll say -1 take away, sorry, -1 take away 5, which gives me -6, and then at the same time, -1 times -5 gives me +5. So the question that you ask yourself when you are factorizing a quadratic expression or quadratic equation is you identify A, B, and C, you find AC, and then you ask yourself what two factors of AC will add or subtract, and at the same will add or subtract to give me B, sorry, and at the same time multiply to give me AC. So in this one it's easy because it's just first of all the coefficient of x squared, a is 1 and c is 5, which makes it a prime number. AC is a prime number. So it literally only has two factors. So then you would rewrite this quadratic in um replacing replacing b bx with the two factors that you chose. So it'll be x squared minus x minus 5x plus 5. I'm literally showing you all the long way because I could have just gone from this straight to the factorized format, right? And then I factorize by grouping. So common between x squared and x is x. X into x squared is x, and x into minus x is -1. Bring down this minus sign. The common factor between 5x and 5 is 5. So 5 into 5x is x, and -5 into +5 is -1. All right, and then as you can see, you have your repeated factor. So finally, this will be x minus 1 into x minus 5. This is a long way of factorizing, right? But in general, I could have gone straight from the first line to the factored format. Now that you have the two factors, you will let each of the brackets equal 0. So x minus 1 is equal to 0, or x minus 5 is equal to 0. So that means if x minus 1 is equal to 0, then x is equal to 0 plus 1, which gives me 1. And if x minus 5 is equal to 0, then x is equal to 0 plus 5, which gives me 5. So my two solutions of this quadratic is x is equal to 1 and x is equal to 5. So I know that when I'm sketching my graph, the roots of the curve will be 1 and 5, right? Because that's what the roots or x-intercepts are. It's the solutions of the quadratic. All right, so I have two things done there. I have my, well, one is that I know that this will be a minimum curve because A is positive. And now I also have the roots of the equation. So if we look back at the quadratic curve, there are three things again that I need. One is the minimum point. Well, two things actually, the minimum point and the axis and the y-intercept. Remember, just now I told you that the y-intercept is the c value from the equation, right? So if we look here, x squared minus 6x plus 5, c is equal to 5. So that means the y-intercept of this quadratic is 5. So the graph is going to cut the y-axis at y is equal to 5. So far, we know that the roots of the equation, roots or x-intercepts, would be 1 and 5, right? So it's going to cut the x-axis at 1 and 5. We also know that the y-intercept is equal to 5, since c is equal to 5. So the y-intercept is also 5. Now I need to find the axis of symmetry. And the reason I will find the axis of symmetry is because the axis of symmetry gives me the minimum point, the x coordinates of the minimum point. So I could find the axis of symmetry, right? The equation of the axis of symmetry by using the equation or using the formula, my x is equal to minus b over 2a. So in this equation, e was negative 6. So that'll be negative 6 actually, right? Because it's minus b. So it'll be minus, let me use black, minus 6, because it's negative b, over 2 times a, which is 1. So that's actually going to be x is equal to negative will be a positive. So 6 divided by 2, which is 3. So my axis of symmetry, my um my x coordinates of the minimum points will be x is equal to 3. And now I need to find out what is the minimum value. Your minimum value, I should have written that here, is the y coordinates of the minimum point, right? Your minimum value is the y coordinate of the minimum point. So to find the minimum value, what I will do is I will substitute x is equal to 3 into the equation to see what y will be. All right. So let's see. So the minimum value, which is the y coordinates of the minimum point, occurs when x is equal to 3. So what we will do to find the minimum value is we will substitute x is equal to 3 into, let y equal the quadratic equation. So into y is equal to x squared minus 6x plus 5. All right, so I'm going to write this one up here. So substituting x is equal to 3 into y is equal to 3 squared minus 6 times 3 plus 5, right? Because the minimum value occurs when x is equal to 3. So you just put this in on your calculator, 3 squared minus 6 by 3 plus 5, and you'll get negative 4. So the minimum value is negative 4. And now I have everything I need to sketch this curve, right? So this is your minimum value here. Therefore, the minimum point will be x is 3 and y is negative 4. So I can sketch this curve. And when you're sketching a curve, it doesn't need to be drawn to scale. You just need to highlight your important parts, right? So I'm gonna draw the axes. So this is my y-axis here, kind of bend, right? And then my x-axis, right? So, right, so this is x and y. I know that the curve is going to be a U shape because it is the coefficient of x squared. A is positive. So what do we have? We know that the curve cuts the x-axis. The roots of the equation are 1 and 5. And then the y-intercept is 5. And also the minimum point is 3, negative 4. So all of the curve, most of the curve is going to be on the right side of the y-axis because everything there is positive values of x. So let's say, no. Might be more like this. Right. So this might be the general shape of it. Like I said, it doesn't have to be drawn to scale, right? So it's fine. Doesn't have to be drawn to scale. So here we have this point here will be 1. That is your first root, your first x-intercept. And then the second point where it cuts the the x-axis is 5. That is your other x-intercept. The y-intercept is 5, so it cuts the y-axis at 5. And then your minimum point, which is the lowest point on the graph, right? The coordinates of this point will be 3, -4. So on the y-axis here, will be -4, and then here is 3. So your axis of symmetry will pass through that line. Point, sorry. This. Very bad. And that's the curve. That is the sketch of the quadratic. Y is equal to, let's write it in. This is the sketch of the quadratic. Y is equal to x squared minus 6x plus 5. All right, so just to go over, if you have a quadratic x squared minus 6x plus 5 and you need to sketch the curve for that quadratic, you need your roots or x-intercepts, which is found by solving the quadratic equation, your y-intercept, which is found by just identifying what is the c value in the quadratic equation, your axis of symmetry, in which the equation for your axis of symmetry is found by doing x is equal to minus b over 2a. That's one way to find the axis of symmetry. The next way, if you already know what the x-intercepts are, you can find the average of those 2 points. So I could have said 1 plus 5 divided by 2, which will give me 3, right? Because the axis of symmetry will be the halfway point between those two x-intercepts. But that would only work if you have two x-intercepts. However, memorizing the formula, x is equal to minus b over 2a, to find the equation of your axis of symmetry will always work for any type of quadratic, regardless of how many roots it has. And then the other thing you needed to sketch this quadratic is to find the minimum value, which is the y-coordinate of your minimum point. So to find the y-coordinate of the minimum point, you substitute your axis of symmetry, the value that you got for x, into y is equal to the quadratic. So y in this case is equal to x squared minus 6x plus 5. So I substituted x is equal to 3 into that equation to find what the minimum value was. There's also a formula to memorize it, but I just can't remember what it was to find the minimum value. I'll check it out just now, but I never remember it. So I always just use this. This is a safe way to do it. All right, let's take a breath. Right, so I just showed you how basically what the features of the minimum curve are, and then I used an example to show you how it would look, right? The same applies, the exact same thing, the same thing that you have to do to sketch a minimum curve is exactly what you need to do to sketch a maximum curve. But before that, I just want to go through the features. It's the same features, it's still gonna have roots, it's still going to have a vertex or turning point. It's still going to have a y-intercept and an axis of symmetry, except the shape of the curve is different. So instead of a minimum point, it's going to have a maximum point, right? So this is what I mean, right? A maximum point. It's U-shaped, but it's an upside down U. It's when the coefficient of x squared, that is a, is negative. Okay, so let's look at the features explained on a maximum curve now. So if we have a maximum curve, 1 second, let me just sketch it quickly. So you have your This is your y-axis. And then you have your x-axis. Right. So a maximum curve now would look like, right? And on your maximum curve, so this is a maximum curve. The reason it's a maximum curve is because it has a maximum point. In a maximum curve, for a general quadratic ax squared plus bx plus c, the a value is negative. So a is less than 0, right? That is a is negative. So once you see a quadratic in which the um the a value, the coefficients of x squared is negative, expect that you're going to have a maximum curve. So like an example of a quadratic might be, let's say 8 minus 2x minus 5x squared. So you see here, a in this case is negative 5, right? The coefficients of x squared is negative 5. It means that this quadratic will have a maximum curve. So let's just identify the features on the maximum curve. You have your x-intercepts, right? Or your roots of the quadratic. That's where the graph cuts the x-axis. So this is root. This is the root of the quadratic. That's one root. And this is another root in the event that the quadratic has two roots. Then you have your y-intercept, right? This here is your y-intercept, and your y-intercept is your c value in the quadratic. Then you have your maximum point. So this is your maximum point, or vertex, or turning point. Those are all words that are used to describe your maximum point. Right? So this is your maximum point. It's also known as the turning point or the vertex. And then you have, of course, your axis of symmetry, which passes through your turning point. This is your axis of symmetry here, right? This is your axis of symmetry. Cool. And then your maximum value will be your y-coordinate of the maximum point. So this is what you would expect a maximum curve. So like this quadratic here, 8 minus 2x minus 5x squared, you would expect this curve to look something like this, to have this general shape. All right, so guys, you have to know how to solve a quadratic like this. You need to be able to sketch a curve for a quadratic equation, including all of the values. So at the end of the class, if we have time today, we'll look at a past paper question, or some. Ideally, what I'd want to do is I want to go through the whole relations, functions, algebra relations, functions, and graphs topic, and then do all of the past paper questions on that. But we'll see how it goes. Guys, let's take a short break, like 5 minutes. So we'll start back at 5:21. Okay, good. I just came back. I just came back as well. Right. So far, we looked at the general form of a quadratic, which is ax squared plus bx plus c, where a, b, and c are all real numbers, and a cannot be equal to 0. We looked at identifying a, b, and c in a quadratic. So, for example, x squared plus 3x minus 7, a is 1, b is 3, and c is negative 7. 5x squared minus x plus 1, a is 5, b is negative 1, and c is 1. And then in this one, 4 minus 2x squared, A is -2, B is 4, and C is 0, right? And we also looked at the fact that once you have a quadratic where the highest power, not a quadratic, sorry, if you have an expression in which the highest power of x is more than 2, so like if it's 3, then it wouldn't be a quadratic. Or if the highest power of x is 1, it still wouldn't be a quadratic. The highest power of x has to be 2 in order for an equation or expression to be considered a quadratic. So that's one thing that we did. Then we looked at the graph of a quadratic, which is called a parabola, and it's a characteristic U shape. It depends on whether A is positive or negative for the shape. Well, the shape of the quadratic depends on that, right? So if A is greater than 0, that is if A is positive, you have a minimum curve, and when A is negative, you have a maximum curve. We also looked at the features of both curves, starting with the minimum curve. The points at which the graph cuts the x-axis are known as your roots or x-intercepts, and they are found by solving the quadratic. So if you solve the quadratic and you get two roots, you'll have two solutions. Sorry, and you have two solutions. It means the curve is going to cut the x-axis at 2 points. If you solve the quadratic and you only get one solution for x, then the curve is only going to touch the x-axis at 1 point. And if you solve the quadratic and you end up with no solution, it means that the curve does not cut the x-axis. All of that can happen, right? Next, we looked at the minimum point or vertex or turning point as it is called. It is the lowest point on a minimum curve. And the x value of the minimum point also is the equation of the axis of symmetry, which can be found by using the formula x is equal to minus b over 2a. The y-intercept, which is where the curve cuts the y-axis, is the c value in your quadratic expression or equation. And then what else? Oh, that was it. That was the major features of the minimum curve. We looked at a full example from solving the quadratic to finding the roots of the x-intercepts and finding all the other features that you need in order to solve in order to sketch the graph of the quadratic. So in this one, x squared minus 6x plus 5, I chose to solve it using factorization. Now, you can solve a quadratic using the quadratic formula, which is given to you in your list of formulae, or you can complete the square, or you can factorize. So you have three ways to solve the quadratic equation. Doesn't matter which way you choose, you're still supposed to get the correct answer, right? So for this one, we found the roots by solving the quadratic through factorization. Then we identify the y-intercept by simply seeing what c was in the equation. We found the axis of symmetry using the formula minus b over 2a. And we found the minimum value by substituting our x coordinates into y is equal to the quadratic equation given to find the minimum value, which is the y coordinate of the minimum point, right? So the x coordinates and y coordinates, so the axis of symmetry and the minimum value makes up your minimum point. And then we sketched the quadratic here. We also looked at what the features would be on a maximum curve. So it's basically the exact same things, except you have a maximum point instead of a minimum point, but the steps in like finding the values to sketch a curve will be the exact same thing. You would have to do you would have to solve the quadratic and then find your minus v over 2a to get your axis of symmetry and all of that, right? So an example of a quadratic that would have a maximum point would be 8 minus 2x minus 5x squared, since the coefficient of x squared here is negative. It's -5. So one thing that I talked about just now is that you can solve your quadratic can have two solutions. It can have no solution, or it can have one solution, All right. And you can figure out if a quadratic, the nature, what we call the nature of the roots, right? Meaning, does it have one root or one solution? Does it have two solutions? Or does it have no solution? So we can look at the nature of the roots by talking about what is known as the discriminant. So the discriminant of a quadratic is found by taking b squared minus 4ac. And that's part of the quadratic formula, which we would recall shortly. So b squared minus 4ac is the discriminant, what is called the discriminant of the quadratic. And based on if b squared minus 4ac is equal to 0, right? Sorry, if it is greater than 0, if it is greater than 0, you will have two real solutions or two real roots. So that means your quadratic would have two roots. If the discriminant is, well, b squared minus 4ac is equal to 0, then you have one repeated root. Right? One repeated root or one real root. So it will only it'll only touch the x-axis at one point. And finally, if the discriminant is if b squared minus 4ac is less than 0, then the quadratic has 0 roots or no solution. So it will not cut the x-axis. So for example, like in this example that we did here, which was x squared minus 6x plus 5, right? When we solved it, we got two real roots. Now, if we just look at that, let me show you. So that's x squared. That was uh x squared minus 6x plus 5, right, is equal to 0. So if we do if we find the discriminant here, b squared minus 4ac, that would be b squared, well, b here is negative 6, right? So it'll be negative 6 squared minus 4 by a, which is 1, by c, which is 5. So this would give me negative 6 squared is 36, minus 4 times 1 is 4, times 5 is 20. So here the discriminant will be 36 minus 20, which is 16. So here, b squared minus 4ac is equal to 16. So therefore, since since b squared, in this case, b squared minus 4ac is greater than 0, you would have, therefore, you have two real roots, which we saw when we solved that previous quadratic, right? Now, let's look at another one. Let's say we have a quadratic x squared plus 4x plus 10 is equal to 0. Well, b here is 4 and here's 1. B is, for this one, a is 1. That's the coefficient of x squared. B is 4 and c is 10. So b squared minus 4ac, let's see what it is. B squared minus 4ac will be b, which is 4, so 4 squared minus 4 times a, which is 1, times c, which is 10. So this gives me 4 squared is 16, minus 4 times 1 is 4, times 10 is 40. 16 minus 40 is negative 36. So in this case, b squared minus 4ac is equal to negative 36. So b squared minus 4ac is less than 0 since it's negative, and therefore this quadratic will have no real roots. So it will have 0 roots, it has 0 solutions. When you solve this quadratic, you're going to end up with no solution. So let's actually use the quadratic formula to solve this quadratic so I can show you why you would have no solution, right? So the quadratic formula, guys, is given to you in your list of formulae on your in your CXC paper, right? So if you don't know it by heart, it's fine. Don't even like feel any type of way. Just even if you think you know it by heart, I would still recommend checking it in the exam if you're going to use it, right? So the quadratic formula is x is equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. So you see b squared minus 4ac there, right? It's the discriminant. And it would make sense why, if the discriminant b squared minus 4ac, if it's negative, why you cannot solve it, because you cannot take the square root of a negative number. But let's put it in perspective here. So the equation was the quadratic, it was x squared plus 4x plus 10 is equal to 0. So solving this equation, let's see. A is 1, the coefficient of x squared. B is 4, and C is 10. So let's substitute those things into our formula. We'll get x is equal to minus b, so minus 4, plus or minus the square root of 4 squared minus 4 times a, which is 1, times c, which is 10, all divided by 2 times a. In this case, a is 1. So simplifying this, we'll get minus 4 plus or minus the root of, well, 4 squared is 16 minus 40, which we got as negative 36. And negative 36 all over 2 times 1, which is 2. At this point, you cannot solve the quadratic. The reason you cannot solve the quadratic is you cannot take the square root of a negative number. So therefore, this quadratic has no solution. So whenever you're solving a quadratic and you end up with a negative discriminant, meaning b squared minus 4ac is negative, you cannot solve it because you cannot take the square root of a negative number. This quadratic has no solutions. Let's look at one that actually has a solution, right? So let's say we have um, I'm gonna try to fit it on the same page. So we could actually, let me not do that. I don't think I'll have space. So let's go to this one. So solving the quadratic, 2x squared minus 6x plus 4 is equal to 0, right? So here, a is 2, b is negative 6, and c is 4. All right, so substituting these values, let's recall the formula first. X is equal to minus b plus or minus the root of b squared minus 4ac all divided by 2a. So substituting our values into the formula, minus b will be minus 6. B is minus 6, right? So it'll be minus 6 plus or minus the root of b squared, which will be negative 6 squared, minus 4 times a. A is 2 and c is 4, all over 2 times a, which in this case is 2. So this would be simplifying. Minus 6 will be plus 6. So just get rid of the minus sign. Plus or minus the square root of, and on my calculator, I'm going to do this, negative 6 squared minus 4 times 2 times 4, which is 4. So I don't need this long thing here. Be the square root of 4 divided by 2 times 2, which is 4. So I will end up with x is equal to 6 plus the square root of 4, which will be 6 plus 2. The root of 4 is 2, all divided by 4. Or x is equal to 6 minus the square root of 4, which is 2. So 6 minus 2 over 4. So this would be 6 plus 2 is 8, and 8 divided by 4 is 2, or 6 minus 2 is 4, and 4 divided by 4 is 1. So the solution to this quadratic equation is x is 2 and x is 1. All right, guys. So that is how you would solve the quadratic using quadratic formula. And you can determine if a quadratic has what types of solution it has, whether it has two real solutions, one solution, or zero solutions by checking what the discriminant tells you. So if the discriminant is positive, if b squared minus 4ac is positive, that is, if it is greater than 0, you have two real roots, as was the case here, right? Not here, sorry, here. Cool. The discriminant here was 4. B squared minus 4ac. B squared minus 4ac was equal to 4 in this case. So that means b squared minus 4ac was positive. It's greater than 0, so you have two solutions, as we saw here. When the discriminant is negative, that is when b squared minus 4ac is less than 0, you have no solution, which was the case here with the quadratic x squared plus 4x plus 10. When we checked what the discriminant was equal to, it was equal to negative 30. Oops, I put negative 36. There should have been negative 34 here. Sorry, I didn't even realize that. No, no, gosh, that is wrong still. 16 take away 40 is negative 24. It's not going to change the answer. It's not going to change the reality. Sorry about that. Negative 24. It's still negative, so you have no real roots, right? So here too, this would have been negative 24 here. You cannot take the square root of a negative number, so you have no real roots. Sorry about that, guys. I didn't even realize I made that mistake. But thankfully, with that mistake, it does not change the answer because you're still not going to have a real root. You will have zero solutions for that quadratic. Now, the third way of solving the quadratic is by completing the square, right? So let's recall the steps in completing the square. Now, with completing the square format, the most popular one in CXC you would see is a by x plus h, all to be squared, plus k, right? Where a, h, and k are all real numbers, right? So this is the format that most times they ask you to represent the quadratic in terms of this a by x plus h squared plus k, right? So let's see how that looks. If you have the equation, let's say we have x squared plus 6x plus 5 is equal to 0, and I need to write this in the completed square format. First things first, in order to complete the square, coefficient of x squared has to be 1. So in this case, it is equal to 1. So I can go ahead and do my steps, right? The first step is you take x, you take half of the coefficient of x squared from here. So half of 6, which is 3, all to be squared. You minus that same 3 all to be squared, and then you add back this 5 here, right? So then this would be, simplifying this would give me x plus 3 all to be squared. Now this will be minus 9 plus 5 is equal to 0. So this would be, finally, it will be x plus 3 all to be squared minus 9 plus 5 is minus 4 equals 0. So at this point here, this quadratic is in the form a by x plus h all to be squared plus k, where a is equal to 1, right? The coefficient of x squared there is 1. H is equal to 3, and k, this case, is equal to negative 4. right? So this is where CXC would ask you, this is how they would ask you the question. To write the equation in the form a by x plus h all to be squared plus k. This is the most popular way that they ask it, right? You could solve the quadratic from here, by the way, because you can now make this as x plus 3 all to be squared is equal to, you move 4 to the other side, so it will become 0 plus 4, which gives me 4. And then to get x plus 3 alone, you would have to take the square root of both sides. So x plus 3 will be plus or minus the root of 4. So then x plus 3 is equal to positive or negative 2. So then x is equal to 2, positive 2, take away 3, or x is equal to negative 2, take away 3. I moved the 3 to the other side of the equation, right? So then x will be equal to negative 1, or x will be equal to negative 5. So that would be the solutions to a quadratic. So you can also solve the quadratic by completing the square like this. So let's look at an example of when the coefficient of x squared is not equal to 1. Remember, you can only solve you could only complete the square if the coefficient of x squared is 1. So when it is not equal to 1, you have to do something a little different. So an example would be, let's say we had 2x squared minus 5x plus 2 is equal to 0. So the first thing we're going to do is represent the quadratic in the form a by x plus h plus k, and then we're going to solve it as well. So first thing, because you cannot complete the square when the coefficient of x squared is greater than 2, what I'm going to do is I'm going to factor it out, right? Meaning that I'm going to take it out of the x squared, so I'm going to divide throughout by that. So I'll say 2, I'm going to use square brackets. So 2x squared, 2 into 2x squared will just be x squared. And then 2 into 5x would actually be 5 over 2. So I'm only going to take it out of the first part here of the x terms, right? The x squared term and the x. And this is equal to 0. Now I can complete the square, right? So completing the square, I'll say, well, this part would be, you take x, you take half of the coefficient of x. So it will be minus half of this would be 5 over 4, all to be squared. And then you minus from it that same 5 over 4 all to be squared, closing my square bracket, plus 2 on the outside. Okay, now I'm going to simplify. So this will be 2 by x minus 5 over 4 all to be squared, minus 5 squared is 25, 4 squared is 16. Close my brackets. Plus 2 is equal to 0. And now I'm going to remove these square brackets because it's almost looking like this format here now, right? So I have to remove these square brackets. So I'm multiplying throughout inside there by 2. So this will give me 2 by x minus 5 over 4, all to be squared, minus 2 times this, which would actually be 25 over 2 into 2, 1, 2 into 16 is 8, plus 2 is equal to 0. Almost in the format, we still have to do one more thing, which is to simplify this part. So you get 2 by x minus 5 over 4 squared minus 25 over 8 plus 2 would be minus 1 and 1/8, which is, what is that? 1 times 8 is, which is 9 over, so this will be minus 9 over 8 is equal to 0. So guys, in the form, this is in the form a by x plus h plus k, where a in this case is 2, right? H is minus 5 over 4, and K is minus 9 over 8. Right? And now I could solve this. I'm going to solve this equation from here. So solving the equation, I'm going to move minus 9 over 8 to the other side. So I end up with 2 by x minus 5 over 4, all to be squared is equal to 0. No, not 0. 0 plus 9 over 8, which would be 9 over 8. To get rid of the 2, I will divide both sides by 2, which will end up being x minus 5 over 4 all to be squared. 9 over 8 divided by 2 will be 9 over 16. All right, I'm taking this up here now. So then this would be x minus 5 over 4. To get rid of the squared, you'll take the square roots of both sides. So you'll end up with plus or minus the square root of 9 over 16, which gives me x minus 5 over 4 is equal to positive or negative. The square root of 9 over 16, square root of 9 is 3, square root of 16 is 4. So it will be plus or minus 3 over 4. Right? So x minus 5 over 4 will be equal to either positive 3/4 or negative 3/4. So if it's positive 3/4, x will be 3/4 plus 5 over 4, or x will be 3/4 minus 3/4, sorry, plus 5 over 4, which gives me 3/4 plus 5 over 4. 3 plus 5 is 8, and 8 over 4 is 2. X will be 2, or minus 3 plus 5 is actually minus 2 over 4, which is minus a half. So the two solutions of x here will be 2 or not negative, sorry, negative 3 over 4 plus 5 over 4 is positive 2 over 4, which is a half. So your solutions of your quadratic there will be 2 or a half. So I know this part might have been a little confusing because, of course, this is only a summary. However, we have I have a full recording from before on completing the square. So today's session, what we've gone through are all the fundamentals. So literally everything you need to know about quadratics is what we did today, right? The only other thing that you're gonna have to do is how do you solve a pair of simultaneous equations where one is quadratic and one is linear. And I also have a video on that. So at the end of the class, I'm going to link all of those videos for you. So at any point, if anything was confusing, tell me. Well, you could tell me, you don't need to. You could actually just go on the YouTube, or actually on the Google Classroom. I would link all the relevant videos so you can go through it. So throughout class today, whichever part, wherever you found it confusing, like if you found factorizing the quadratic was confusing, then it would make sense to go watch a video on factorizing the quadratic because we have one on that. If you found um the features of the quadratic was confusing, we have that as well. So as we go through these kind of sessions, take a note of what you find was a little confusing and what you need to do some more work on, what you might need a refresh on, because during your study session, you can then specifically focus on that. So today, just to recap what we did, we looked at the general form of a quadratic, identifying A, B, and C. We looked at the graphs of quadratics, the minimum and maximum curve, and what are the features of each. We looked at actually solving a quadratic and sketching it, so finding all the features, which are the roots, the y-intercept, the axis of symmetry, the minimum value, the minimum point, which it's going to be the same for a maximum as well, right? So we looked at doing that. We reviewed the discriminant. What does it mean in terms of the types of roots or the number of solutions a quadratic will have? Discriminant, if it's greater than 0, that is, if it is positive, you have two real roots, which means that the quadratic will have two solutions. If it's equal to 0, you have one root or one repeated root. And if it's less than 0, you have 0 roots. We looked at that as well with some examples. And then we looked at using the quadratic formula to solve a quadratic. We looked at one where it had no solutions, and we also looked at one where there were two solutions. And then finally, the last thing was expressing a quadratic in the form a by x plus h all to the squared plus k, which is the general form. And when we do past paper questions on this again, you'll see CSEC asks you for this form often. Now, they could use any letters. You could use like P and Q, any letters, but generally, these are the letters that they use. But more importantly, what it means is to complete the square and represent the quadratic in completed square format. So we just went through how do you do that, first of all, and then how do you solve the quadratic from the completed square format. Like I said, at any point, if any of these things gave you some difficulty, then it could be a guide as to what to study next, right? So some of you came in late, but I would have already shared with these students, with the other students, that each of you I've made a study timetable template for each of you. So let me just go back to that before we end class today so I could show you what it looks like and what I want you to do, because the official study timetable starts from next week, right? So this is what it looks like, and I made one for each of you. All I've included in it so far are your math lessons, the days that you have math lessons with me, because I don't know what other lessons you have, as well as the dates of the exams for English and math. Again, because I know all of you are doing English and math, right? So your task is to go, I'll share each of these documents with you, and you need to fill in for me your other lessons as well as your official CXC exams. Now, even though you don't have your physical timetable with you, you can go on the website and you can find the timetable here. Just search CXE 2026 um, June June timetable and you'll get it, right? So when I send you your individual Google Sheet, you're gonna go in here and you're gonna fill in for me, one, your extra lessons, and two, the official dates of your exams. So the days are divided into session one, session two, and session three. Now, right now, because you're in school, you would not have a session one because it's school. So it will just be blank probably. Unless you're staying home some days, then you should do something, right? Session two is 4 to 6 p.m. And right now on Thursdays you do math. I don't know if you have other lessons, but you'll have to like fill it in there for me. Okay, so that's what I want you guys to do when I send it to you tonight, because as you can see, it starts from Monday, 16th February, which is next week Monday, right? And it's also the sheet is divided into four 4 week periods. So weeks 1 to 4, weeks 5 to 8, weeks 9 to 12. It's actually 12 in the 12th week that CXC is starting for you, for most of you.